Hello everyone. Now we are going to look at another example to solve this shortest path by Dijkstra's method. For the graph below, find the shortest path from A to F. Now we are going to list all the nodes with an alphabetic order: A, B, C, D, E, and F. The start node is A. The finish node is F. Now we are going to pick your start node A. Then we start from node A to A. Yes, we walked 0 distance. And your start node is A. We put it in the corner A. Now we start from A and then we finish at B. The distance is 8. Then to B, the previous node is A. So we put A in the corner. Now let's go to C. From A to C, we walk a distance of 9. And the previous node is A. Now let's look at D. From A to D, you can't go there straight away. So we just put down infinity. If we go to E, that is a distance of 7. Then the previous node is A. So we put down A in the corner. Now let's go to F. Since F, you cannot go there straight away from A, so we also put down infinity in this box. Now let's look at this row. Which number is the smallest except 0? Because 0, we have used the node A. We can't use it anymore. Then now we choose the next smallest number, that is 7. Okay, let's circle number 7. So for number 7, the corresponding node is E, which means if you go to E, the shortest distance is 7, and you start from A. Now we will put node E as our active node. Let's see, if we go to A from E, of course, we don't have to do that anymore because go to A, that is 0 distance, we copy it here. And then we go to B from E. Yes, we can. That'll be 7 plus 1, which is 8. And same distance, like from A to B. So we don't have to change it. We just keep it the same. As long as you have no update, no better path than the previous number, you just copy the previous one here. Then let's go to C from E. Can we? Yes, we can. If we go to C from E, it'll be much longer. And the shortest distance to C is still from A to C, which is 9. So we copy it here. Now let's go to D. If we go to D from E, yes, we can. That will be 7 plus 8. That is 15. And if you go to D, the previous node is E. You put E in the corner. Now let's see. If we go to E, yes, the distance is 7. That is always the shortest one, 7A. Then if we go to F, yes, we can go to F from E. That will be 7 plus 4, which is 11. The previous node will be E. So we put E in the corner. Now let's look at the second row. Which number is the smallest, except number 7 and 0? Because we have used the two active nodes, A and E. Then the next smallest number will be number 8. So here we will be circling number 8. Which means if you go to B, then the shortest distance is 8. And the shortest distance is 8. And it starts from A. So we put B as our next active node. Now let's see. Okay, go to A. The shortest distance is always 0. So we keep it the same. If we go to B, the shortest distance is 8, and you start from A. Then if you go to C, the shortest distance is still 9, and you start from A. If you go to D, what is the distance? If you start from A and then go through B and then go to D, it will be 8 plus 5, which is 13. And when you arrive D, the previous node is B. So we put B in the corner. Now let's look at how do we go to E from B. Yes, we can. If you go to E from B, it will be 8 plus 1, which is 9. But it's longer than 7, so we don't use it. We still keep it the same. We never update until you find a smaller or shorter path than this number. Then let's see, how do we go to F? If we go to F from B, then we can use this way. It will be 8 plus 9, which is 17. Since 17 is bigger than 11, we don't update. We still keep it the same. Now let's look which number is the smallest, except 0, 8, 7 we have used. The next number will be 9. Let's circle number 9. Then we can see if we go to C, we will have the shortest distance at 9, which you start from A. Now we will choose C as our next active node. Now let's see. Go to A, the shortest distance is 0. You go to B, shortest distance is 8. You start from A. Then if we go to C, the shortest distance is 9. We still keep it the same. Now if you go to D from C, yes, you can. That will be 9 plus 6, which is 15. And you go to D, the previous node is C. We put C in the corner. Now let's go to E. If we go to E from C, yes, we can. We go this way, but it will be much longer than this way, 7. So we still keep 7 the same. Then now let's go to F. If we go to F from C, yes, we can, but it will be much longer than 11. We can see that, much longer than 11. So we don't update. We keep it the same. Okay, now let's look at the fourth row. Except number 8, number 9, we have chosen. Then which is the smallest number? 7 we also chosen. The next smallest number is 11. So we pick 11. Okay, now we have found the shortest distance to F, which is 11. And the previous node, you go to F, the previous node is E. Okay, now we have solved the problem. Can we please go back to check what is your root? So you got the total distance 11, and your destination is F. Let's see. F, the previous node is E. Now we check E. If you go to E, the shortest distance is you come from A. Okay, we got it? We check this table, we can see how do we go back, which means we come from A and then we go to E, we go to F. So the shortest distance is from A to E to F. And the distance is 11 kilometers. I hope this video is very clear for you to understand Dijkstra's method. I'll catch up with you later. Bye-bye.